All right, number one. So it says when 150 joules of work, 150 joules, external force, 15 newtons, time is 20 seconds. The total energy of that in system increases by what? Uh, so work is change in total energy, right? That's on your reference table. And so work literally means changing total energy. So if you do 150 joules of work on this system, then the energy of that system increases by 150 joules. Energy is measured in joules, work is measured in joules. So it literally gives you the answer. So if you don't know how to do scientific notation, put a decimal after the first number, two decimal places, so 1.5 times 10 to the 2 joules. So it's A. Number 2, a block initially at rest, accelerated by a constant horizontal force, 5 newtons. Work is 15 joules. The kinetic energy of the block increases by what? So what is your change in kinetic energy? Well, here's the thing, right? So if work is change in total energy, and total energy is basically change in potential energy plus change in kinetic energy plus change in internal energy. And so, well, if it's only horizontal, this is only a horizontal surface. And so your height is still doesn't change. If your height doesn't change, then potential energy doesn't change either. And we want to find out what KE and so about internal energy. Well, it says frictionless surface. So if we're moving on a frictionless surface, we don't lose energy due to friction, which means we don't lose energy due to heat. And so our delta Q is 0. Okay? Uh, so work. So 15 is equal to a change in kinetic energy. And the question wants you, well, what's my change in kinetic energy? My change in kinetic energy is 15 joules. And so the answer is B. Answer is B. 3. 15 kilogram mass, right? 15 kg mass. Initial velocity 7.5 meters per second. Final velocity is 11.5. And we want to know what the work, what total work done to this mass must be to change my velocity. So again, let's set this up. Work is change in total energy is going to change in P plus change in KE plus change in Q. All right, so my work is change in potential energy. Again, it's a horizontal surface, so your height doesn't change. If your height doesn't change, but potential energy doesn't change either. Change in kinetic energy, we'll leave that alone for now. It says frictionless, so there's no loss due to heat, internal energy. So right now our work is change in kinetic energy. And change in kinetic energy is final kinetic energy minus initial kinetic energy. Break it down further. Final velocity minus 1/2 initial velocity. So 1/2 15 11.5 squared plus 1/2 m, which is going to be 15 7.5 squared. The answer is going to be 570 joules. All right. Number 4. Motor does 20 joules of work, so the work is 20 joules. Neglecting friction, yet the gravitational potential energy is block increases, so the change in potential energy is 15 joules. And the change, so what is the change in kinetic energy? So again, we have this equation, change in ET is equal to change in PE plus change in KE plus delta Q. Since work is 20 is equal to change in P is 15 joules plus change in KE, and it says frictionless. So ignore friction. So our loss due to internal energy, due to heat, due to friction is 0. Minus 15. Minus 15. 5 joules is our change in kinetic energy. So if we're moving up, right? If we're accelerating upward and our velocity increases, well, our kinetic energy increases by 5 joules. So it's B. B, B, B. So let's backside. Calculate the total amount of gravitational potential energy. So what is PE? Pulls a mass 72 kg. Bottom to the top, so the height is 40 meters. Exerts magnitude, force is 158 newtons. Move a skier a total distance of 250 meters up the side of the hill. Sure. So the horizontal distance traveled is 230 meters. So I'm gonna separate this into height and distance because I can. So just follow along for now. So my potential energy at the top only matters about height, right? So my potential energy is mgh. So mass is 72, g is 9.8, positive 9.8, and h is 40. 10, 400, 400, 70. 400 times 70 is 28,000 joules, somewhere around here. All right, it might be off a little bit. It might be off a little bit. Hell, who the hell cares? So around 28,000 joules. That's potential energy. So 6 is describe what happens to the internal energy of the skier hill system as the skier is pulled up the hill. Well, there's friction on the surface. Uh, so the internal energy of the skier hill system increases, right? As you're being pulled along the hill, you're gonna lose energy due to heat, due to various energies. So your internal energy of the system increases. Describe what happens to the total mechanical energy. So again, mechanical energy is ET. So what happens to your total energy as you go up this hill? Pulled up the hill. Your total mechanical energy of the skier hill system increases because it stays constant speed, right? Constant speed. So your kinetic energy, which is 1/2 mv squared, stays the same. So stays the same. But as you get pulled to the top of the hill, your potential energy increases, right? So while I have no potential energy at the bottom, my kinetic energy is the same at the top as it is on the bottom. So even though my kinetic energy stays the same, my potential energy increases, so the total mechanical energy uh, increases as well. So increases. That's